Welcome back. So, this was the last portion we were discussing about the different channel pattern, and we also discussed that what are the possible indicators of active tectonics that we see in terms of the manifestation with along the river valleys and different channel patterns in form of different channel patterns. So, then we also discuss about that local meanders, local development of braided pattern, widening and narrowing of the channel, local development of ponds, and these are the. So, if we are not having consistently this sort of indicators or the channel pattern for a longer distance, then we need to check whether what are the reasons for this local changes in the channel pattern. Could be related to your active tectonics. So, these are the two figures we have already discussed in the previous lecture. One was about the channel pattern, which has been given by Shum from 1 to 5, and then about the sinuosity and its relation with the slope actually. So, usually it has been seen again, I would like to emphasize here is that at initial stage when the river is subjected to, even the river bed is subjected to uplift or subsidence in terms of the tectonics. So, last lecture also I have I was explaining. So, usually the channel profile has been seen that in typical way like this, okay. But suppose there is an change in the channel profile, suppose it is going up or down, and this is what you are having an uplift, this portion. So, this portion is your uplift and this is your subsidence. So, depending on what channel pattern you have in the upper reaches, and while it crossing the portion which has been affected either by the uplift or subsidence, depending on that. So, suppose you are having for example straight, so you may see a different pattern over here in the channel, and then further downstream you will have a different pattern. Okay. So, if you are having meander, then you will have different channel pattern. So, that I will talk at the end, that what type of channel. So, basically what ingredients we are putting in and what we are getting output as an output, that will vary based on the ingredients we are subjecting to the. So, in order to maintain the constant gradient, because as I told that the channel will always try to keep itself in equilibrium. So, it will try to maintain its profile. Okay. So, if there is sort of an uplift, it will erode. If there is a subsidence, then it will grade. That is a very normal process which we will come across in such areas. Okay. So, in order to maintain the constant gradient, a river bed is being steepened by the downstream tilt will cause increase in sinuosity. So, this basically says that if you are increasing the gradient, okay, steepening the gradient means you are having, suppose you have a profile coming like this, and then suddenly you see the fall, okay, over here. So, this you are looking at the steepening of river gradient. Okay. So, this basically you will have to keep in mind. Okay. So, this increases sinuosity. Okay. So, channel if it is like straight, then in downstream you will see that its sinuosity has increased. So, this will also give an indicator of that increase in sinuosity in the local region. Okay. Whereas, reduction in the valley slope. Okay. When we say reduction, that means we are uplifting the area. Okay. So, this means this profile as the steepness has reduced. So, that will reduce your sinuosity. So, here steepening increase the sinuosity and reduction in valley slope will reduce the sinuosity. So, this is also experimentally proved, and slight increase in valley slope with shift will shift the river pattern from left to right. So, this has been for this pattern. So, there is, if there is an increase in valley slope, so the pattern will be from straight to braided or maybe braided straight, and then you are having sinus channel and all that. Okay. So, with greater change of the valley slope, it will result into incision and increase in sediment supplies, that is change of mix load channel to bed load channel. So, this again is, it has been like what has been shown, we have already discussed this, that if you move from this portion to this side, actually what we are seeing is that, and this is also related with your shape of the channel or the pattern of channel pattern from straight to braided, and that will be your due to greater change in valley slope. Okay. So, that will result into the even the sediment supply will also increase, and which is going from suspended to your bed load. Okay. So, aggradation and degradation, as I was explaining in the previous slide, that if you consider this, I will just change the. So, if you are looking at the gradient here, so this will, the river will try to maintain this gradient. Okay. But due to the tectonic movement, your area has, like for example, this is the area which is subside, but this is getting uplifted here, and then you are having the subsidence here. So, you see a sort of an uplift here. Okay. So, this component has warped the area in the region. Okay. So, what will happen here is that this portion will have a gradation, and this will degrade, and this will again have the gradation. So, gradation is, you can say this portion. Okay. This portion will aggregate. So, there will be deposition here in this area, that is the process of aggradation, and this portion will have degradation. So, this is in case of, you can say, uplift. So, deposition upstream and downstream of the uplifted area, and incision, that is your degradation in your uplifted portion. So, this portion will have a typical like landforms, which you can talk about the fluvial terraces. Okay. So, this will be because of the incision. Now, in case of subsidence, what will happen? So, this is again what you are looking at here, that this is sort of, we can say, a reduction in gradient. So, reduction in gradient we see. So, reduction is related to your uplift. So, reduction here will degrade this area. Now, in this case, what we are having? Steepening of valley slope or gradient. So, this portion has resulted into the subsidence actually. So, the original profile, as we were talking about, is I will just show with this one. Okay. So, this is the original profile, and because of the subsidence, this portion. So, basically this will, the river will try to bring itself along in this line actually. That is what we were talking about, that it will try to bring itself in equilibrium. Okay. So, since the valley has the slope has changed, so this portion will will aggrade. Okay. So, deposition will take place, but this portion will be eroded. So, this will have what we were talking about, incision, and this will have erosion actually. So, this is this will be having deposition. So, these are the two cases which helps us in understanding that what will happen when there is a sudden change in either by the reduction or steepening of the channel slope. Okay. So, river incision, the region of steepened slope due to faulting and aggrades downstream as it enters into the area of subsidence. So, this is the area of subsidence we are looking at. So, such cases can be well studied if we come across the landforms, and if we are looking at some degraded areas or sudden aggradation has been seen. So, that can help us in also identifying the, and of course, the channel pattern will also helps us in identifying that whether this area is affected by the tectonic movement or not. Okay. So, again this is what has been shown, that how it will like react, the channels will react to the uplift and the subsidence area. So, depending on what type of pattern you have, that will result into, for example, you are having like an uplift here. So, you may see a sort of, and this is an example here, that you have an anastomosing channel here, it will get into the, in the downstream it will become sinus. Okay. Similarly, here if you are having like sinus channel, then it becomes, it goes into anastomosing and so on. Okay. So, these are the indicators. So, change in the channel pattern is caused by increase or decrease in valley slope due to uplift or subsidence of the area respectively. Okay. Decrease in slope will cause river to like rivers braid to meander actually. That what I was showing here, braid to meander to straight actually. So, from braid then you will have to straight. So, depending on what type of pattern you are having before the anomaly, like either it is uplift or it is you are having an subsidence here. Okay. So, based on that you will see the. So, most commonly observed stream adjustment is from meandering channel, is for the meandering, for a meandering channel. So, increase in sinuosity in response to increase in slope, or decrease in sinuosity in response to decrease in slope. Okay. So, I have one example from US which shows clear indication of this effect, and even from India also we have marked certain examples looking at the response of channel pattern to tectonics. Okay. So, let us see that. So, like but before we go into that detail, okay, we can also just look at what. So, this is the area which is like, I will just explain this first. So, this is your Himalayan frontal region, which demarcates the boundary between the Himalayas and the youngest mountain chain. This one is your Janauri anticline, which marks the plate boundary. So, this is your Janauri anticline, and this is your plate boundary, which is between so this whole area is the plate boundary between Indian plate. So, this side will be Himalaya, this side is Tibetan plate, and this side is your Indo-Gangetic plain. So, the example which I was talking about, that change in the sinuosity and how it will affect. So, let us see the example from here in this region, what we have we looked at. Okay. So, this is the fault line of just behind the Janauri anticline. Janauri anticline is this one here. So, that what I was showing, not exactly Janauri anticline is here, but this is your Nahan thrust, okay, you call, and this the whole picture which you see is from this area. So, this is the reservoir of so this one is this reservoir of Satluj, and then so this image has been like shifted, we have changed the direction over to see this information, but here also you can, if you carefully look at, you can see this sinus channel. Okay. So, let us see this and that we, so what we identified was that there is a thrust here, thrust fault. So, if I put the cross section across this, then it will be something like what we see, that this is coming up and then you are having like this one. Okay. So, there is a thrusting which is taking place. So, what we see in the hanging wall side, as this is a tight meander actually. So, if you check look at the channel and check its sinusity, then you will be able to understand that. So, we have like almost more or less straight channel, but close to the uplift what we are able to see is the incision also, as well as we see meandering here. Tight meandering is been seen here. I am not able to draw here because it is not clear, but yes, if you tilt a little bit more, you will be able to see. So, what we have here is straight, and then downstream also what we see is straight. Okay. But in between here we have increase in sinusity. So, basically the meandering loops are increasing here and they are tightly meandered actually. So, these are typical of indicator of active tectonics. Okay. Now, if you look at the common drainage pattern and geological significance, then these are the types which are been given. Dendritic description is there and geological significance. Okay. So, for example, dendritic channel if you are having, then you have irregular branching of the stream, and basically it looks like an like a tree. Okay. So, it resembles tree. So, if you take the tree trunk here, like, and then if you try to put the small stems, it will be typically, it resembles like a tree actually. So, and this I am drawing this is the upstream area. So, this is typically of like a branching nature you will see. And what is the what are the geological what informations you can generate from this, that the material is homogeneous. Okay. And if you are having like crystalline rocks, older harder rocks you are having, and also if you have the horizontal beds, then you will see this, and then slope is gentle, gentler regional slope. Okay. So, and then you have subdendritic peanut, but if you see rectangular, for example, so I will just talk about few and rest you can read out again. So, streams have a right angle bend. So, you will find that the streams are flowing in typical right angle bending. Okay. So, and this is mostly it has been controlled by sets of fracture. Okay. Okay. Or joints of fractures, and very common in sandstone and quartzitic areas. Then you have again angular. So, you have acute angle in this is right angle, this is acute angle. Again parallel trellis are also important one. So, very most common you will be coming across this one which I am putting. Okay, radial, then you are having even centripetal also is there, but mostly you will come across this type of drainages. Okay, parallel. So, they most of the channels will be parallel, and these are indicative of steep slope, also in areas of parallel elongated landforms. Okay. So, parallel elongated landform something like this, and if they are having steep slope, you will see that the drainages are almost flowing in a parallel fashion. Okay. Then trellis are actually usually we try to look at the trunk stream and the tributaries actually. So, that main stream, that is a trunk stream and the tributaries. that what is been observed, that they usually join at right angles. So, for example, you are having a trunk stream which is flowing like this. Okay, this is your trunk stream, and the smaller streams, that is your tributaries, will keep joining in almost right angle to that. Okay. Now, this has been seen that if you are having the area which is folded, okay, folded sedimentary rocks are seen, and folded sedimentary rocks, if you are talking about, then mostly you will come across the sand and sandstone shale intercalations. Okay. So, that also will be, so mainly we are having like harder and softer rocks. So, that will result into the formation of treatise pattern. Okay. Then radial, mostly you will find that you have like they are originating from the center and then flowing away in different directions. Okay. So, this is again an sort of an, you have domal areas at the center. Okay. So, if you come across the center part is uplifted. So, if you take the cross section, then it will show something like this. Okay. So, mostly in the areas where you are having an domal regions, that will show your radial pattern. Okay. Now, I just wanted to show that this is how you can extract the drainage, and this was been done using SRTM data and the shaded relief map. Of course, the DEM is there. So, we were able to extract the drainages from this, and the bold blue line is the major stream. Okay, that is your trunk stream, and then you are having the minor stream. So, these are all fold belts here, and if you carefully look at, this is what I was talking about. This is a trunk stream, and almost it is coming and meeting at right angle streams and all that. Okay, even these streams are meeting the, because for this stream this will be trunk stream, and for this stream this is a trunk stream here. But based on the drainage, one can also try to understand that what is the landform we can identify. Okay. So, if you carefully look, I am just putting a line here. Okay. So, because based on that, there are these streams are flowing in this direction, and this stream are flowing in this direction. Okay. So, what we have been talking about right from the beginning, that if you are having the slope in any area, that will result into the on that slope. So, for example, you are having a slope in this direction here, and this stream will flow in this direction. If you are having slope over like this, okay, then this stream will flow in this direction. Okay. So, it will follow the slope, and this line which I have drawn here, this line is exactly your what we say is the drainage divide here. Okay. So, this is your drainage divide. So, I am drawing very rough figure over here. So, this is your drainage divide, and this is your slope of the area. Okay. So, again, if you draw here, then you have the streams which are flowing on, and similarly in most of the areas you will be able to identify. One such area, if you see closely, then this one, okay, what we are able to judge is that is some sort of an radial pattern which we are able to see over here. Okay. I'll come to that part if I have slide, but the previous one which I was showing, one of the slide where we have seen the tight meander, that slide is having. So, tight meander was over here in this area, and then just above that, if you see here, this area is almost the radial pattern. That, so radial pattern, as we have discussed in the previous slide. So, it talks about something like domal portion. Okay. So, slightly uplifted or and circular. So, this is the area actually what I am talking about. Okay. So, this area, the warped area, which we are talking and I am showing there. Okay. So, this is the area. So, this is basically showing typical of a radial pattern here, because the streams are flowing away from the center. So, again as I told that there are a couple of patterns which are most common. So, out of that is dendritic, and as I was talking about, it appears like a tree trunk, and the streams which are bifurcating from the main trunk stream. Then you have rectangular trellis, we have the main stream, and then you are having these tributaries which are following the softer rocks mainly, and these are the resistance rocks, resistive rocks. Okay. So, these are the harder rocks, but these are softer rocks. So, mostly you will find that the valleys are been cut and they join the trunk stream at right angle. And if you are having radial, then either you are having a volcanic cone or a domal portion. So, with this I will stop here, and we will discuss little more in next lecture. Thank you so much.